Hi, I'm Becky Stern. Today we're going to build some simple circuits without the need for any code or programming. I'll show you how to hook up some LEDs to a battery pack and also a simple circuit for playing audio. Let's start with a simple LED and battery circuit. You will need a standard 3-volt through-hole LED, a resistor somewhere in the 100 to 300-ish ohm range works great, a 3 AAA battery holder, and a switch if your battery holder doesn't have one already, as well as some wire and some heat shrink tubing. Here is a diagram of a basic LED circuit. As we covered in a previous video about LEDs, the positive side is connected to the battery's positive side and likewise negative to negative, with the resistor in series with the LED. The current will flow from the battery through the resistor and LED and then back to the battery. The resistor limits the current flowing in the whole circuit, regardless of whether it comes before or after the LED in the circuit. It'll work either way. And resistors aren't polarized like LEDs, so their orientation doesn't matter. Tin and solder the components according to the diagram, and don't forget to add some heat shrink tubing before the final connections. But if you're new to soldering, you may want to hold off on actually shrinking it until you've tested that it works first. Install your batteries, verify their orientation, and flip the switch. Your LED should turn on. If it doesn't, double check for a short circuit, 2 wires that are touching that shouldn't be. If you have a short, parts of your circuit may start to heat up. Remove the batteries right away if this happens and correct the short before plugging them back in. To test what's connected and not, we'll use a multimeter set to continuity mode. With the circuit off, I can touch the probes to either side of the connection in question, and if it beeps, it's connected. And if it doesn't, it's not connected. You can check the whole circuit for things you know should be connected and things you know that shouldn't be. To add more LEDs to this setup, just wire them in parallel with the first one, meaning that each LED and resistor pair is connected to the battery at the same point. All the positives together and all the negatives. See, now you know the difference between series and parallel circuits. The resistor and LED are in series with one another, and the multiple LEDs are in parallel with each other. Beginners often ask if they can put just one resistor in series with the multiple parallel LEDs. Makes sense in theory, but while this may work in a simulation, it's not a good idea in practice, and it'll eventually cause one or more of the LEDs to fail. This is because they aren't perfectly even conductors, so whichever LED has ever so slightly less internal resistance than its neighbors will start to attract more current, which over time will become more pronounced and even burn out the LED. Try adding just 2 or 3 more LEDs before making any big plans to add a bazillion more. You can learn how to calculate the battery life in a different Digi-Key video we'll link in the description. Once you start mixing and matching colors, which are electrically different from one another, the individual resistor values start to matter a lot more. Remember that electrical current takes the path of least resistance. So now that you know how to build a basic circuit with LEDs and resistors, I want to switch gears completely and make a sound circuit. This easy-to-use audio FX board makes it possible. And it's not as complex as it looks. The board connects to your computer over USB, and it shows up like a flash drive. I drag the sound files onto it the way I would any other flash drive. I did have to format the sound files according to the board specs, which I did using the free audio editing program called Audacity. The way the files are named determines which trigger they are associated with, as well as the behavior. For example, I can make one trigger play randomly from a set of sounds by naming them accordingly. To trigger the sound to play, one of the labeled connectors on this side of the board needs to be connected to ground, either permanently with a wire or temporarily with a switch. To hook things up, I'm going to use a solderless breadboard. The holes grip onto the wires you plug in and are connected in a particular way on the inside. You've got 2 long rails down each side and then 2 columns of connected rows in between. The components go in the middle. See how the board's legs neatly line up so each one is in its own row? And then the rails are used for power and ground, anywhere you need access to it. So I've hooked up the audio FX board and then wired switches from these trigger pins to ground. The speakers plug into the built-in amplifier here at the terminal block. And that's all there is to creating a simple audio circuit. Once you've got it working on a solderless breadboard, you can transpose it over to a soldered breadboard to make it more permanent and embed it inside your project. I've put links to some resources in the description, including the Digi-Key circuit calculators and the video about calculating battery life. Do try these out and let me know how it goes in the comments. Don't miss the playlist with the rest of this series and subscribe to be sure you don't miss the next one.